right, thanks, Liz. Alrighty, so for the unfortunately large portion of you that need a security plan, today will be obviously right up your alley. We're going to talk about SQL Server 2016 security. We're going to focus on the 2016 release of SQL Server. So from the first poll there, it seems like a fairly large percentage of you all are actually running at least some 2016 box in your environment, whether all your servers are on that or whether it's just one server. At least you have one out there to get you going on it. If you don't have a SQL 2016 environment, I would definitely encourage you to get out there and spin one up, whether you just download a copy of something like Developer Edition and install it locally on your laptop or in a virtual machine on your laptop, or whether you go out to Azure and spin up one of the images out there in the gallery that's already got it installed, because there's a lot of stuff in 2016, especially for those of you that are on generally or mostly using an earlier version of SQL Server. There's a lot of new stuff in the 2014 and 2016 releases that are potentially good for you there. So today, like I said, we're going to focus on 2016 security. There's several really cool enhancements that we've got here that are new to the product. These aren't just updates to existing features. These are brand new features in there, so we'll take a look at those. Real quick before we get going, a little bit about myself. My name is Brad Schacht. I work for Microsoft. I'm a data platform solution architect on the state and local government team. I was actually a consultant with Pragmatic Works there for about 6.5 years before moving over to Microsoft. I blog a little bit here and there on bradleyschacht.com, so if you want to get the follow-up with the Q&A after the webinar, I'll also post the scripts and everything that I use for the webinar and everything out there. So be sure to check that out if you want to be able to take some of these samples and get some hands-on for yourself. And then I also speak, and as Liz and I were talking, I'm a fan of pizza. So also the Braves when they're not terrible. So real quick before we hop into the actual security features that we have in the 2016 environment, let me tell you just real quick here one slide about how SQL Server is developed. And the reason why this is somewhat important is just for you to understand where you can get certain features. And a lot of companies like to wait a version or two for SQL Server before they install them because they're not sure, they want to wait for the patches to come out and all that. But SQL Server right now is developed much differently than it was back in the 2000, 2005, 2008, even up to 2012. So basically what happens right now is everything pretty much goes into the cloud first. So we have the SQL database offering out there on the Azure environment. And when we launch new features, we generally put it into SQL database first. But by the time you see it in SQL database, it's actually gone through several iterations. So we do internal previews of those, or just the product team. They do internal previews with different departments inside of Microsoft to let them try it out. Then they go into private previews with just a couple of customers, but tested in real world scenarios. And then it gets into a little bit broader private preview where some more people can get into it, but not everybody can get into it, again, to test it in some of those real world scenarios. And then by the time it finally goes GA, and then makes it into the box product, into regular SQL Server, we've probably already tested it for, on thousands and thousands of databases and gotten a lot of feedback from customers in a very production type manner. So these are actual real world scenarios that the software is being put through in order to test it and find the bugs and make it better for everybody before it actually makes it into the product. The only reason I bring this up is because SQL 2016 is still fairly new. It's only been out for about a year. And like I said, a lot of companies have some apprehensions about going to it, but I only tell you this just so that you know the versions of SQL Server that you see now are much more tested than any version or any feature that you've ever seen in any previous version of SQL Server, which is why we can go from before having going from a SQL 2000 to a 2005 release, and now we're going from SQL 2016 to SQL 2017 this year by being able to test this a lot more thoroughly in the cloud environment. So with that, let's talk a little bit about the couple of features that we're gonna look through today. The three that we're gonna look at are always encrypted, where we've got some encryption options in SQL Server currently if you're in the 2012 and previous environments. We're gonna talk about a new feature called always encrypted that allows us to encrypt data end to end, basically all the way through your applications. Dynamic data masking, something that's not necessarily new to the data world, but is new to SQL Server. And same thing, row-level security. Again, not something that's new to the database world, but something that we've just implemented here inside of SQL Server in 2016, and we'll show you how each one of these are going to work for us. So, dynamic data masking. Dynamic data masking is, again, something that you've probably seen in other places, but we've had to do some hokey workarounds inside of the SQL Server world in order to mask some of the data. So why would we want to mask data? Essentially, it's to prevent users from seeing data that they shouldn't see. So let's take the scenario where you end up having to call your cell phone provider or your internet provider. Usually if you're having to call them, it's probably not the best circumstance. So maybe your bill is wrong and you want to give them a call and you want to try to get things fixed, or maybe your service is out or something like that. But the first question that they're always going to ask you is, hey, I want to verify that you are who you say you are. So when I call my cell phone company or I call my internet provider and I say, hi, this is Brad Schacht. I need to complain to you for a few minutes about my bill being wrong. Why did you charge me an extra $50? This whole deal. The first thing that they're going to say is, okay, well, verify your phone number, or verify your your date of birth, or verify the last 4 digits of your credit card if you're calling your credit card company for something maybe. So there's a lot of different things that they might ask you. But the key here is that that person on the other end of the phone, if I call my credit card company and they say, give me the last 4 of your social, I want to know that they don't see my entire social security number. Same thing with my cell phone provider. If I call them and they say, well, okay, give me the last 4 of your credit card number that's on your billing information. I don't want them to be able to see my entire credit card information, because chances are, one, they shouldn't be able to see it anyway, but 2, if I'm about to go and yell at this person for 15 minutes about why they're doing something wrong, I don't want to make that person angry, and then they've got my credit card information or my social security number that they can go sell on the internet someplace. So it prevents users from seeing data that they shouldn't see, that they shouldn't need to see or be able to see. So this is where that personally identifiable information comes into play in a lot of places. So there's a variety of reasons why this is beneficial, from regulatory compliance, where people just aren't allowed to see your entire birthday in most situations, or again, the social security number, where they're just not allowed to see your social security number, to just, data is being just protecting your customer base. So whether it's information that legally they are allowed to see, but companies just want to put in some extra protections so that they can tell their customers and reassure their customers that they are being good stewards of my information. So that way, when I go and I sign up for something, I know that they're not going to just go out there and show every person inside their organization my address, for instance. Okay. The reason why data masking in SQL Server is a good implementation is because we actually handle all of this at the database level. So what normally happens if we need to mask this data inside of our applications is that we go and we modify the application. So if I have a web front end that an application, a web UI that I've built, usually we would go into that web application and we would modify the code and say, hey, anytime somebody brings back this social security field, I want you to mask everything except for the last 4 of the social. Or I want you to mask everything. I only want you to show the year, or the day and the month of the birthday. I don't want you to show them the year. That way they can't figure out an age or anything like that. So we end up having to make application changes. The reason why this is great for SQL Server is because it happens at the database engine level. What that means to us is that it doesn't matter where I consume the data, whether it's consuming the data inside of reporting services, or whether it's inside of something like Power BI, or whether it's inside some sort of a custom application that I build. It doesn't matter what I do there. I can just write a regular T-SQL statement and I don't have to modify the data. It means as the data is read off of disk from the database, that is when the masking is going to be applied. That means that any application that uses this data, or whether I use it inside store procedures or anything like that, the data is going to be masked as soon as it's pulled off of disk. It means everywhere it's used is going to be masked. Okay? There are some masking functions that are built in, and I'll show you a couple of these in a demo here in just a second. of how we can use some built-in functionality to mask these, and then a custom function so you can apply your own custom masking as well. You'll notice one note on the screen there, the second to last option, or the second to last item. It says, by default, the database owner is unmasked. So that's a very important thing for everybody to take away here, is that if you are in the database owner group, or you are listed as the database owner, then you will not see the masked version of the data. It doesn't matter if the data has a masking function applied to it or not. If you are database owner, you will not see masked data. So that's something key for everybody to remember there. Okay, everybody else though will see the masked version of the data. And you can set, there's an unmask option so that you can say individual users, so maybe HR is allowed to see certain data, but sales is not allowed to see certain data. So you can mask and unmask based on usernames or roles as well. All right, so let's take a look at what this actually looks like in an actual database environment here. Okay, so I've got my application connecting to my database, and inside of my database, I'm going to do a couple of things. I'm just going to say alter table, and then tell it which column I want to mask, and then tell it how I want to mask it. So if I want to mask it with the built-in email function, then I'm going to say mask the email column using the email function. If I want to have the salary column, as you'll see there in the sample code, if I want to have the salary column show just some random value so people don't know how much my employees actually make when they query the data, then it's going to put a random value between 1 and, in this case, 20,000. The key with all of these, though, is that none of the data on the servers are actually modified. All the data is stored in its normal, actual, real data points, but this data is masked again as it's brought off a disk. And then in this case, that admin 1 is going to have unmasked permissions. What that looks like from a query perspective, this is the great part about this feature. Again, this feature, the next one with RowLevel Security, as well as Always Encrypted, the great thing about all of these is that your T-SQL looks exactly the same. Like there's nothing I have to do, there's nothing I'm referencing inside this T-SQL query that says, hey, give me the masked or unmasked version of the data. The server knows based on your login whether or not you're allowed to see the masked version of the data. And then if you're the admin, as the far right would suggest, then you're going to see the unmasked version of the data. If you're any other user, you're going to see in the center there the other login data where all the data is masked. Right? So real quick before we actually take a look at the demo, last slide here for limitations. Just know there are a couple of limitations on these. You can't actually put masking on a computed column, but you can put masking on a column that's referenced inside of a computed column. So if I have a computed column that adds the salary and the bonus field together, I can't put a masking on that computed column, but I can put a mask on the salary or on the bonus column. Okay, so just a couple of things to keep in mind there as you're using this functionality. All right, so here I've got my database that I'm connected to up in Azure there. You'll see the server is bs-srv SQL 01, and we've got two databases in particular that we're going to be looking at here. We're going to use the AdventureWorks data set today, and then this oil and gas demo. And I'll have a little bit more info about that oil and gas when we get in here in just 1 second. Okay, so let me open up a little script here and copy some code, so I don't have to sit here and write tons of lines of code for you guys. And again, I'll provide this script for everybody on my blog afterwards so that everybody can see this later on if you want to take this for a spin yourself. Okay, so for this particular data set here, we're going to use the oil and gas data set. And the data that we're going to be looking at here is inside this user base PII data. So I've taken some data from inside my data set here, and as we look through here, we can see that there's probably some information that's irrelevant if people see it, like this org node, that very first column. Probably doesn't matter if anybody sees that. The employee ID more than likely doesn't matter if anybody sees that because it's just a random integer value there. It's an auto-incrementing value. Then we've got user IDs and names. But then we get over here into some other information that potentially we don't want everybody to be able to see. So email address, birth date, and social security number. These are things that maybe we don't want every user inside of our application seeing, but we still want to have some of that data available. Again, for the birth date, maybe we only want to have the year showing, or the social security number, we only want to provide the last 4. So now that we've seen the data set here a little bit, let me just show you a couple of functions here. And we've got, these are the 4 functions that we have built in today's world. So default, email, a custom string, and random. And I'll show you how each one of those operates here. So I'm just going to apply the default function to a few different fields here. So what we're doing is we're saying that I want to mask the org unit name, the employee ID, and the birth date just using the default filter, using the default mask here, okay? So the reason why I chose these columns is that gives us a text field, an integer value, and a date column, just so you guys can see what the default values do for us, okay? Again, if I were to come up here and I were to run this select query again, you'll notice that all the data here is unmasked. So we know we just ran this function here to mask that data, but the reason why I see all this data, again, is because I'm running right now, I'm connected as the SA user. So I'm connected with a user that's part of that database owner group, and so they're going to be able to see all the data inside of here. However, if I come over here and I execute the same exact query as this eCross user, you'll see now we get a little bit different data here. Okay, so you'll notice that our date field, everything is listed as 11-1900. Our email address is listed as the first letter of the email address, bunch of X's at xxxxx.com. And then the org unit name, again, a text value or a string, barchar, is going to be just 4 X's. Okay, so that's what the default is going to do for us, which means anytime a user comes in and runs that, whether it's through an application or whether it's here inside a management studio, they won't be able to see the actual data. Okay, they're only going to see that masked version. Okay, so I'm going to go ahead and this time I'm going to modify the email address. So you'll remember before we did the default on the string. This time we're going to go to email, and I'm going to look at this one. So that's the same value that we just saw a second ago. So the first letter, a bunch of X's at bunchofx's.com. Here's something I want to call this out specifically and show this to you, because that's what the email function does, is it does the first letter and then .com at the end. The reason that this is important is for folks like me. So I work with government agencies. So I work with government customers who have a lot of email addresses that end in .gov. Well, that default, if I use the function, if I used email as my function, you'll notice what it did. It still does the first letter and then .com at the end, even though the actual data set down here is the first letter and .gov at the end. Okay, so just be aware of that the email function doesn't necessarily take the actual ending of your email address. It defaults it to a .com email address. So just something to be aware of there. Okay, so I'm going to go ahead and reset that so I've got this ready for next time I need it. And then let's go ahead and look at something, the custom functions that we have here. So what this function is going to do, I'm going to go ahead and run this. And what this function here is going to do is it's going to take my social security number column, and instead of using a default or anything like that, I'm going to say that I want to partially mask the data. And this is a custom function that we can do. What partial is going to tell us is that we want to take this many leading characters, some constant value that we're going to display here, and then this many trailing values from the field. So in this case, if my my social security number is formatted like this in my data set, what is going to come out the other end is going to be 0 leading characters, so no leading characters here off the beginning, and then it's going to be XXX dash XX dash, and then the last 4 characters, so the trailing 4 characters of the data set there, and then that's going to be my 1111. Okay, so that's what the partial is going to tell us to do. If I had said I wanted to do partial a 1 here instead of a 0, that would look like this. It would be a 1 and then XXX dash XX dash 1111. Okay, so I would take 1 leading character, I would have this constant value, and then the last 4 characters there. Okay, so let's take a look at what that looks like when we actually run the query here. Okay, so as expected, we end up with a bunch of X's, and then the last 4 characters of that social security number there. One other thing I'm going to show you here inside of this when we do the partial is that I can put anything inside of there. So it says I can put something here, and then I want the last 4 characters. So take a look at what happens though whenever I run this query and I bring the results back. Notice that it actually comes down here and it actually truncates the data set. So I put in, I can put anything here and then 4. So I should have seen I can put anything here and then 1, 2, 3, 4. But what happens here, and this is a really important piece of functionality here, is that I'm never going to, my masking function is never going to be allowed to overflow the data type of the data that I'm bringing in. What that means to me is if my application expects a varchar, or expects a string that's 10 characters long, and I come into my function, my masking function up here, and I put something that's more than 10 characters, it means that it's not going to break my application. So that's a very important thing there, is we're never gonna give you more data back than what the data type allows. Okay? And then just a couple of real quick things here at the end as we roll on. This random function, basically we're saying that I want to display a random number between the number 1 and 100 for the employee ID. So as I run this, take a look at the employee ID. We've got 54, 13, 99. If I run this again, I get 92, 69, 5. So it's taking that, and every time, each time I run the query, I get a different random value between the number 1 and 100. Okay, so something that's interesting, and you know, this is kind of a use case for you to depend on whether or not this is okay or not okay. But notice here that I can still run this query. So even though this column is masked with a value between 1 and 100, I can still run the query, show me user where the employee ID is 1001. So again, that column is masked, but I can still run this query. Take a look at this. So as I run this, if I notice the employee ID every single time is a different value, but it still lets me run that query there. So you can get past the masking if you run enough queries and want to figure data out. You certainly can do that. So just know that that functionality is, that is how that functionality works. One other thing, last piece here, and then we'll move on to RowLevel Security, is temp table. So the question inevitably comes up every time I talk about RowLevel Security. Somebody says, all right, well, I can do where clauses against this. What's preventing me from just putting this data into a temp table and getting the actual data? Well, that's where the actual implementation of this comes into play. And that means that, again, as I mentioned earlier, as soon as the data is read off of disk, so as soon as the data is queried, it is immediately masked. What that means to us here is if I were to run this query and I were to put data into this temp table and run it as a user that can't see the actual data, look what happens to the data set here. So you'll notice that the employee ID, let me zoom out just a little, the employee ID is that random value here still. The email address is masked, the date of birth is masked, and the social security number is masked. So that right now is pulling the data from my temp table, but we don't actually allow them to see the underlying data set there. So from a security perspective there, that's a good thing so that users can't just go in, create temp tables, make a copy of the data, and circumvent your data masking there. All right, a couple other queries that I'll have included here. So you can see the different columns that are masked using some system tables, and then what functions are being used on those. And then I'm just going to go ahead and reset my demo here for next time. Apparently that column email underscore address. There we go. And away we go. All right, go ahead and close this out here. And let's hop back over into our slides just for a moment here. So the key use cases here for data masking, again, protecting against unauthorized disclosure of sensitive information in your application. So again, as you saw, this was driven by the user. If the user does not have unmasked permissions, then they only see the masked data. Any database owners, they are going to be able to see the actual underlying data set there. So just keep that in mind. Great thing about this, again, is that there's no changes that need to be made on your application. As we mask the data, we're going to keep the same data types, and we're going to never overflow the data type. So again, if I have a varchar 10, we're never going to allow more than 10 characters to come back in that query there. Okay. All right, so that's data masking. Next thing we're going to look at here is something a little bit more complicated, and that's going to be row-level security. So there's been a lot of different ways to handle row-level security over the years. None of them have been super flexible or a lot of fun to implement, because generally what ends up happening is that you've got some sort of table that stores all your relationships that says this user is allowed to see X stores, and that's perfectly fine. You know, that's easy enough to manage and maintain and reference and all that. But then you end up having to build views, or you have to build store procedures in order for users to be able to access the data, because you have to take those security tables that say who is allowed to see which data points, and you have to combine those somehow, and then you have to reference the user in it, so you know which user is accessing the data and what data they're allowed to see. So it becomes this weird implementation where you have to build views and store procedures, and then you have to modify those views and store procedures anytime schema changes. It just doesn't become flexible. It's not maintainable. So what we've done in 2016 here, again, is built in row-level security directly into the engine. So this is going to allow us to either table drive this or just drive it based off a username, and essentially say which users are allowed to see which rows inside of a data set. So we're going to take this also one step further. So not only are we going to prevent users from querying data that they're not authorized to see, but we're going to go one step further and say this security not only applies to read operations, but also to write operations. What that means to us is that I can't take a record and I can't update a record that I can't see. Okay, so I can run an update statement that updates all the stores in the United States, but if I'm only authorized to see the stores in Florida where I live, then I'm only going to be able to update that handful of stores. Okay, it's going to be transparent to the users. It's going to be transparent to the application. This is all handled in the actual database engine. The other thing that we're going to be able to do is say that you can't insert data. So if I want to go in and mess with the sales numbers for somebody else, I can go in and I can insert data and put fake sales inside of there and get them in trouble if I really wanted to. Well, with row-level security, we're saying that if it's not my region, so if it's not my Florida stores, then I'm not allowed to insert data, I'm not allowed to update data, I'm not allowed to delete data outside of my data set. Okay? So that becomes a very powerful implementation of this, being able to have that flexibility to not only control read operations, but also write operations. Okay? There's a lot of different use cases for this. One place where I've used this a couple of times now is with some Board of Elections customers. So every single campaign that has to, or that goes out or that registers, they all have to disclose certain financial information. Well, the laws are in a lot of states that not even the Board of Elections folks are allowed to see that data before the campaigns by the deadline release it and say, okay, here's our final campaign finance numbers. Well, that's all great, but when the Board of Elections hosts that data, they have to make sure that their employees aren't allowed to see data for campaigns that they're not associated with. So what we do is we put in row-level security there, and we say if your email address or your login doesn't match up to the campaign inside of a little cross-reference table, then you're not allowed to see the data. What that allows them to do is the DBAs, if the DBAs ever query those campaign finance tables, they don't see any data at all. They see 0 results returned. But they can still go about doing their job. So they can still do their index rebuilds. They can still do their backups and restores and all that kind of stuff. But it doesn't actually modify or harm the fact that, or the data integrity, and it doesn't matter that they can't actually see the data. The data still exists there on disk. They just can't select it. Okay, so that's a perfect use case for the multi-tenant databases there. You know, marketing companies have that same sort of situation there, where they've got a lot of different customers all stored inside of a common database or common set of databases there. Okay, there's a couple of different pieces that have to be put in place here. There's a predicate function, so we're going to build some sort of a function to implement this security here. And I'll show you those here in just a moment. So all of our security is driven by UDF, user-defined functions. The predicate here, the actual security predicate, it tells us what we're doing. So we're going to either filter data which is a select statement, or we're going to block operations if it's an insert or an update. And then the security policy kind of brings all those pieces together. So what table am I applying this to, and what columns am I using, all those sort of things. Okay? And we will show you an example of all these, obviously, here in just one second. So again, some other code examples here. We're not going to spend too much time on that. I'll have those slides out there for you guys if you want to review those couple of code samples there as well later on. So in the real world, what this would look like is a situation. Let's take a situation where you've got maybe a nurse and they're inside of a hospital or inside of a doctor's office, and they've got a set of patients that they're in charge of. Well, nurse A should not see all the patients for nurse B that nurse B is covering. So whenever I go into my application, I need to make sure that no matter who selects data, that they only see the patients that they cover. Okay? So what we do is we create this security policy and we apply it to the patients table. And then whenever the nurse goes into their application, again, key thing here is that's the same query, that same select query that you're used to seeing. No difference there, nothing that we have to change inside of our application. But as soon as that user runs that query, it's going to go into the database, and transparently in the background, we're going to do these semi-joins and cross-applies and all these things in order to apply the filter predicates for that security policy. That means that when this nurse goes in and selects star from patients, it's going to go in and look at which wing she's, in this case, that she's working in and what her employee ID is, and she won't be able to see anybody's data except for hers in this particular scenario here. Okay. All right, again, just some sample code there that we'll take a look at a little bit later. So from a performance perspective, this is essentially the equivalent of applying a where clause or using just a regular user-defined function, just like you're probably used to using in your normal environment. I'll show you two examples, one that's pretty simple and then one that's a little bit more complex. Something that's interesting here and something to keep in mind is that these policies can be disabled. So you probably want to have some auditing in place that says that will alert you anytime one of these policies is disabled, because you don't want your DBA team going in and just disabling the policy, downloading a bunch of data, and then re-enabling the policy and nobody have any idea that ever happened. So you do probably want to have some auditing put in place there as well. The key difference here between this and what we just looked at with the data masking is that with data masking, we had the database owners were allowed to see the data. Here with RowLevel Security, it doesn't matter who you are, it doesn't matter if you're the SA account that you're logged in with, you will not be able to see the data unless the security policy defines that you can see the data there. Okay, so let's go ahead and take a look at some code and actually see this in action here. So let me open up my RowLevel Security code and get a copy of this and paste this in here. Okay, so again, we're going to be using this oil and gas data set. Full transparency, I didn't actually create this data set. I'll have a link in my on my blog over to this data set and everything that was put together for it. It's a gentleman named Jamie Johnson, I believe, Johnston, was the one that put this together and used it in a presentation at Summit a couple of years ago, probably about, I guess, year and a half or so ago now, whenever some of these features were just coming out and showcasing some of this stuff. So, you know, again, I didn't put this data set together. It's a really great data set. It showcases everything from data masking through RowLevel Security, all kinds of stuff that's built in there. I've just kind of taken some of it and modified it for my own presentations here. But if you do want to get a copy of this data set, again, I'll have a link to it inside of my blog for you so that you can download this and you'll have the same data set to use as I'm using here. And then again, of course, we'll use the AdventureWorks data here in just a moment for some of the always encrypted functionality. All right, so I'm going to go ahead and run this just to refresh some of the tables here and then do a little bit of cleanup just so that nothing exists here before we get started. All right, so what I'm going to do here, if we take a look at this SEC user map table, let me just do a select star from here. Okay, so if we take a look at this table here, it's a very simple table. All this table shows is the user ID, the hierarchy node, which is a level of a hierarchy. So we go from the from the division to the group to the team, and then down in below that we've got some oil wells that we're taking a look at, some gas wells. Okay, and then the hierarchy value. So at the asset group level, we're saying that this person is supposed to be allowed to see all the PRB data. For this particular person here, they're allowed to see any data that's associated with Texas Gulf, and so on and so forth. So this person's allowed to see anything that falls under the international level. So no U.S. data, only non-U.S. So this person here they would probably be able to see the Mozambique data, but they wouldn't be able to see Gulf of Mexico. We'll dig into this a little bit more, but just for right now, know that there's a user ID. There's one record in here, 159 records, one for each user, and then this is what we're going to use to drive some of the security in just a little bit. Okay, so what this first function here is going to do for us, this is a pretty simple example, is we're going to pass in the user ID from this particular table here, and we're going to say I only want to show the records that are associated with the user running the query. Okay, so I'm going to say is the user ID, the column from this table, does it match the user that's currently running the query? Okay, yes or no. If it does, then this user value for this table value function here is going to return a result. We don't really care what the result is. We just want to know that there is a value that comes back, which is why we usually just select 1 in here. Because the value of this doesn't show up in any user queries. We just need to know, does a value exist, yes or no? So I could select panda in here, and it would probably be just fine for me. Okay? Nothing is actually being used from this query. We just need to know, is there a record, yes or no? Okay, so I'm going to go ahead and run this. And then the way that I'm going to reference that, the way we're actually going to use that, is I'm going to create myself a security policy here. In this case, I'm going to put it in a schema RLS for RowLevel Security, and then I'm going to call this one my record policy. Okay, and what we're going to do is we're going to filter the data. So anytime that you see filter predicate here and nothing else, that means that we're filtering the select statement. So this is the equivalent of putting a where clause on here. Okay, so filter predicate. And what function do I want to use? Okay, again, in this case, we're going to use the function that we just created. Okay, what value do we want to pass into that? So this is going to be a value from a field from my table, is what that's generally going to be here. Okay, so we're going to pass in a field from my table into this function, and then this is going to be the actual table that we're defining it on. Okay, so from my SEC user map table, I'm going to pass in the user ID. The user ID is going to be passed into this query here, and it's going to say if the user ID exists in this result set, then show the user that result. If it does not exist in this result set, then don't show the user that result. Okay, what that looks like to us in the end is if I come over here into my security and I look at my security policies. Okay, notice there's that my security policy that I just put in place there. Okay, so my records policy is the one we just created. The other thing that we created inside of here was inside my programmability, and then in my table value functions, you'll see there's my my fn my records. So that's the fn my records that we just created there. So those are the two objects that we just got done creating. So again, if you remember what I said, if you're a regular user, then you don't get to, or even if I'm in the SA, I don't get to see any data. But if I come in here and I select the data with eCross, I should only see the eCross record. This person here, I only see their record. Okay, so that's the simplest example we can do. There's no other tables involved. We're just going in, seeing if the username matches the username inside the table here. Okay, so I'm going to go ahead and drop those. All right, so again, we'll kind of hop through this real quick just so we can get to the always encrypted functionality here. But what we're looking at here is we have a division, a region, an asset group, and an asset team hierarchy. Okay, so what we're saying is if I define my security at the division level and I say you're allowed to see US, then I'm allowed to see anything in any one of these asset teams. If I define the security at the region level and I say that you're only allowed to see Kenya, you're only allowed to see this one asset team. If I define it at the asset group and I do Gulf of Mexico, then I'm going to be able to see both of these asset teams in my data set. Okay? The way that actually gets mapped over to the users is inside that table that we just looked at. Okay, so these two combined are what is going to define our security. All right. So if I look at my well master table here, and let me clean up a couple of things. So if I look at my well master table, what I see is I have a well, and I can see here's that hierarchy that I'm defining, and here's the production for each one of those wells. So again, if I select this data and I'm only allowed to see, if I define my security at the division level for the US, I shouldn't see this record, this one, or this one. If I define it international and say the opposite, define a division for international, I should be able to see only those 3 records whenever the data set comes back. And then there's, of course, a lot more records inside of here. All right. This one's going to be a little bit more complicated, and again, there's a lot of ways that you could implement a security policy like this. This particular one, we're going to pass in the well ID, and then we're going to run this query here to see whether or not the particular user has their security defined at the division level, the region, the asset group, or whether they're allowed to see everything. And then we're going to see if that particular well ID for the division level of that well is inside the, for that user's hierarchy where their security is defined. Okay, so we're inside of our well master table. We're passing in the well ID field. Pull that back up one more time so everybody can see that. So inside this well master table, we're going to pass in this well ID, and then we're going to see if the division column here is defined for that user. If the user doesn't have division defined, then we're going to go and say, or see if the region is defined for that user. If that's not defined, we'll keep going down the hierarchy there. Okay, so I'm going to go ahead and put this in place, and then I'm going to create one more function here. We're not going to get to that one, but we'll create it anyway just so this doesn't fail. And then we're going to say I want to create this security policy. I want to define it on the well table, and I want to pass in the well ID. So that way, whenever I run these couple of queries here, I can see that for this particular user, they're allowed to see everything. The hierarchy that their security is defined on is all, which means that when I go and I select the data out of my well table here, so you'll see I'm selecting it from the well master, I could just as easily come in here and do a select star. So I just did select distinct so you can see the actual data pieces that are returned here. But if I did select star, we would see that all 100 wells come back inside this data set. Okay. If I go to this next user here, we'll see that their security is defined at the division level, and that they're allowed to see the international wells, which means that when the data comes back, I only get back the international data. Okay. If I hop down one more, this one here is defined at the region level, so the next level of that hierarchy, they're allowed to see northern U.S. So again, I only see the northern U.S. and all the data sets below that. And we could keep going through here, but I'm not going to keep running these over and over again. I'll hop down here and just run one last one for this E-cross guy, because he has no security defined, meaning he's not allowed to see anything, which means there's no data that's going to be returned here for that particular user. Okay, so a lot of flexibility there inside of these functions here. I'll have a bunch of different examples in here for you guys to be able to take a look at. If you have any questions, feel free to reach out to me. Either leave a comment on the blog post for it or shoot me an email, which is on the second slide there inside of my slide deck. So let's go ahead and hop back over here into our slides, and we'll talk about always encrypted real quick before we wrap up here. Okay, so good use cases for row-level security, providing that fine-grained access control. Again, you can block write operations in there as well. There's some sample code for you guys inside the scripts there if you want to take a look at those. All right, so as far as encryption goes, we've traditionally had transparent data encryption available to us inside of SQL Server. What transparent data encryption is, for those of you who are unfamiliar, is it's encryption at rest. What that means is that when the data is sitting on the disk, it's going to be encrypted. As soon as it's pulled off the disk, it's going to be decrypted. That also means that all my backups, my data files, and my log files, and my tempdb are all going to be encrypted. Okay, so whenever I turn that encryption on or off, it encrypts all of those items. My backups going from here on out will be encrypted, and then tempdb as well as my data files and log files. Okay, The key that's important here is that the two things. One, it's decrypted as it's read off disk, so it means it's in plain text after that, and it's at the database level. So I can turn this on or I can turn it off for a database. I can't do anything in between. That brings up always encrypted. So always encrypted came out of the use case that we wanted to have basically end-to-end encryption inside of our data sets. Okay? So what always encrypted is going to allow us to do is encrypt the data not only while it's on disk, not only while it's in the backups, not only while SQL Server is indexing it or doing any of those type of operations, but all the way from the database into the client application, meaning it's encrypted as the data is passed over the wire into your application. That also means that the decryption happens inside of your application. Okay, so it's not going to be decrypted at all inside the SQL Server engine. The data will only be decrypted once it gets to your application. So this means that nobody can go and grab packets off of your network and end up getting some data from inside of those even. So there's no way for anybody to get to your data outside of your application. Okay, this does require you to use a particular driver because the driver is where the decryption actually happens. So you'll notice that there's the ADO.NET 4.6, JDBC, and ODBC drivers there. So you do have to use one of the newer versions of that. Again, end-to-end encryption, a lot of different reasons why you might want to use this depending on your particular industry there. I'm not going to belabor those points so we can get to a quick demo here and show you how this actually works. Okay. So again, as I write the data, whether it's going into or out of my application, on the client, that's where that trust boundary is. So that's where that unencrypted version of the data is actually going to be kept. So if my social security number field is encrypted inside of my database, probably a good idea, it's going to be in plain text while it's shown inside my application or while I'm inside my application typing it in. Okay, so if I get a new customer and I need to type in their social, I have to type it in. It's going to be plain text at that point. As soon as it goes through that ADO.NET driver, though, to pass it over to my database, that's where that data is going to be encrypted. Or in this particular case, if I select data out of my database and I put a where clause on there that says where social security number equals something, it's going to pass that where clause even over into my SQL Server in an encrypted manner. Okay, the data is going to be brought back, again, still going to be encrypted, and whenever it gets returned into my data set inside of my application, that is where it's going to be actually decrypted. Okay. Two types of encryption that we have available to us here are randomized and deterministic. There are some implications behind both of those, so just so that you're aware. What randomized means is if I have the same value and I put it into my database multiple times, then I'm going to get multiple ciphers for it. So it's going to be stored as a var binary, which means, you know, as you can see there in the little screenshot, 1, 2, 3, 4, 5, 6, 7, 8, 9 has 2 different ciphers for it. So those, I can't just go find all the people with that social security number. Hopefully there should be only one, but I can't find that that data in there just by knowing what the cipher for it is. Deterministic, on the other hand, if I put the same value in multiple times, then it's going to have the same ciphertext, the same var binary value every single time. That means that we can use that in joins and where clauses, but your user still won't be able to see the actual data until it gets decrypted inside of your application. Right? There's a couple of different pieces that go along to this. There's a couple of different key structures. You know, we won't spend too much time here. If you have any questions on this, you know, again, feel free to email me. I can get you some more information on any of these pieces. The key here, though, is that no actual keys are stored in the database. So your database stores a location where the actual master key can be found, but you don't actually store the key in the database or on the database server. So that way, if somebody logs into your database server, they still can't get to your data because there's no key values or anything like that stored there. You have to have access to the certificate in order to be able to decrypt the data, and I'll show you what that looks like here in just 1 second. All right, last slide or two here, and then we'll get into the demo for this one. Again, as I issue a query against my SQL Server, what's going to happen is it's going to run some stuff to figure out whether or not the columns that I'm requesting are whether or not they're encrypted. In this case, my social security number column is encrypted, as you can see in the little screenshot there, a little bit of ciphertext. What it's going to do is it's going to pass back a few pieces of information in this case. Where is my certificate? Where is that certificate stored at? Here it's stored in the certificate store on my local computer, and then it's going to give you the thumbprint for it, so it knows how to identify the correct certificate on your computer. What that's going to do is then pass that into the driver, so that ADO.NET or JDBC driver, whatever that happens to be. It's going to go look for that certificate, in this case on my local machine, and then it's going to be able to decipher the text. If that certificate does not exist on my local machine, then I will not be able to decrypt the data. Okay? So let me show you here what that actually looks like to us in real life. So I'm going to skip through a couple of things just because we're running low on time here. But what I'm going to do is I'm going to open up my tables, and I'm going to open up this user base encrypted table here. So what we've got inside of this data set is a social security number field, and you'll see right now it's in plain text. The way that I'm going to go about encrypting this, I'm just going to right click on my table, and I'm going to say encrypt columns, and this is going to run me through a little always encrypted wizard. Okay, so first thing here, column selection. What column do I want to put this on? I'm going to put it on my social security column. Do I want this to be deterministic or randomized? I'm going to say deterministic. We'll click next. Okay, if I already have a key generated, I can use an existing master key. But in this case, I don't have one yet, so I'm going to go ahead and generate one inside my certificate store. Where am I going to store that? I'm going to store it under the current user option here. On servers, you can also use local machine, so we're going to do current user. And then I want to go ahead and proceed now. You can also script this out with PowerShell to generate that script and apply the encryption there. All right, so this is going to take just a moment here, and what I'm going to do is I'm going to launch my cert manager, MSC. And what I'm going to do is I'm going to go into my current user certificate store under personal and certificates, and then you'll see here there's this always encrypted certificate, probably going to be the second one here, and there we go. So now if I rerun this here, let me close that out. Encrypted, script the table, make sure the encryption's on there. You'll notice that the definition for my table has changed just a little bit. You'll see that this is now encrypted with this CEK auto 1. And if we go on here into my security, we'll notice that always encrypted keys, we've got those two keys there. This key here is just telling me where to find this master key. So where do I find this certificate here? So if I go and I run this query again, hopefully it will show me the encrypted values. No, not encrypted. Not sure why. Let me go up over to my server here, fire up my little application and see if it pops up. Localhost, oil gas demo, and I believe this will give me an error message. Okay, so good. So what this is saying is the reason why I get an error message is because I'm trying to pull back the encrypted data and the application is trying to decrypt that data right now. But since that certificate, if I go here into my cert manager, you'll notice that the certificate doesn't exist here inside of my on my server. So what I'm going to do is I'm going to close this out, and I'm going to come over here and I'm going to export this certificate. Okay, yes, password, and I'm going to just throw this onto my desktop, and I hope I'm exporting the correct one because there's two of them in there. Okay, so now I'm going to hop over here onto my desktop. I'm going to copy this certificate over to my server. Okay, and then I'm going to import it. Type in my password again. Okay, imported successfully. If I refresh this now, I should see that certificate inside of here, and hopefully I got the right one. And this time, whenever I connect to that table, the encrypted, I do get data. Now I can see the data inside of here, and I can see the decrypted version of it. So I no longer get that error message. One thing just to be aware of here is if I delete this certificate from my computer, so it no longer exists, in theory, I shouldn't be able to refresh this data here, but if I do get data, it still will show me this data. The reason for that, in order to keep good performance, we only check that certificate when the first time the application needs it. So because I kept the application open, it's already got the information that it needs to decrypt that data. Whereas if I were to close this now and reopen this, which means it's going to initiate a new connection into my database, and I go to find that data set, I'm going to get that error message again. So the connections, as long as the connection stays open, even if you revoke the certificate, they'll be able to continue using the application. Generally not an issue because the application, usually you're creating and closing connections every time you log into the application, so that shouldn't be an issue there for you. Okay. So real easy way to do that. There's a lot of options as far as how you actually store that data or how you actually do the authentication, whether you do certificates or whether you use something like Azure Key Vault to maintain that. Both options are perfectly viable. I've used both of them in the past. Key Vault just gives you a little bit more flexibility because you can drive it by user, you can drive it by machine. Whenever you drive it by certificate, you just have to make sure that that certificate lives on every server where the application is running. Or if you run the application on users' desktops, that certificate would have to be on the desktop. The nice thing about Always Encrypted, though, is the only thing that you have to do is you have to change one little piece of the connection string, and I'll show you this and then we'll wrap up. The only thing that you have to change is you go into your connection string, and this is the exact same connection string as I would normally do, except for I'm going to add this little guy here that says column encryption setting equals enabled. And that right there is what tells your application, hey, if I see an encrypted column, I should be decrypting that value whenever it comes back. Okay. So there's certainly some limitations with this particular piece of functionality with the Always Encrypted functionality there. I've got that information inside the slide deck, which I will make available for everybody. And I'll go ahead and toss up my my slide that has my email address on there in case anybody would like to email me any follow-up questions. And I'll also put my blog on here so you guys can go download those slides if you would like to later on as well. Okay. And Liz, I will hand it back over to you for the last moment.
All right. Do you have time to answer a couple questions, or?
Yeah, absolutely. Sure.
Okay. Has data masking gotten any more secure since it first came out? I heard that when it first came out, it broke in about 2 minutes.
I have to know what they meant by broken in 2 minutes. I know there's been some changes since they first had it in some of the CTPs, but I'm not sure exactly what they'd mean from the RTM. If they want to email me, my email address is up there on the screen. If you want to email me some details about that, I'd be happy to talk with you a little bit more about that, though.
Okay. What will the computed column show if any of the base columns are masked?
So it will use the masked value in the computed column there.
Can the row level be multi-level, like nurse sees only hers, but her manager sees all nurses?
Yes, absolutely. So as long as you build the function to check the correct level of that hierarchy there, then you'd be able to do that. Just a matter of coding it into that user-defined function to ensure that it's checking the correct thing. But that's a very common use case to say like a store manager is only allowed to see their store, but a district manager can see all of the stores in their district. Same kind of concept. Certainly able to do that there, yes.
All right. And just to confirm, what edition of SQL Server are these security features available in?
So it's available in 2016 Enterprise Edition, and then I believe all of these are also available in 2016 Service Pack 1 Standard Edition.
Okay.
So if you are using Standard, again, check SP1 would be the key there, because I know there were some changes with SP1 where we took a lot of these type of features and we pushed them back into the Standard Edition just so more people could have access to them.
Does SSIS lookup work on encrypted columns?
Yes, so if you want to use SSIS, just make sure that you're using the ADO.NET connector instead of an OLADB connector, but all the transforms and everything will work fine. At that point, as the data comes through the source or through the lookup transform or any of those pieces, when it's pulled in through there, that's when the data would be decrypted. So at that point, SSIS is your application. And again, that server would have to have access to your encryption key or that encryption certificate in order to decrypt that data. But yes, that will work.
How easy is replacing certificates when they expire?
More difficult than you want it to be. If you want to be able to do easier certificate management, the easier way to manage that type of functionality is going to be through something like Key Vault or another HSM hardware security module, I think is what that stands for, that will allow you to drive that either based on machine or based on user, and that way you don't have to worry about rotating the actual certificates. I'm sure there's ways to do that through PowerShell or maybe through group policies. I just don't know that it's super easy from what I've seen anyway.
Does RowLevel Security affect performance, or how does it affect performance?
RowLevel Security, your performance hit on that is basically going to be the equivalent of doing a where clause or depending on how complex your function is, of just joining it to that table value function. So if you've got a bunch of nested queries inside of that function, obviously that's going to cause a bigger performance hit than just saying where column equals username. So it's kind of dependent on how well you write that code and how much you put into that, but it shouldn't be more of a performance hit than a simple join.
Okay, I'll just do 2 more questions.
Sure.
How can we see decrypted data from SSMS?
Ooh, great question. All you have to do, I'll actually show you that here real quick. So this right here, that column encryption setting equals enabled that I had mentioned to you guys. If you disconnect and I do a reconnect here, what you want to do is you want to go to options, and then you want to go to additional connection parameters, and you want to paste that inside there. So column encryption setting equals enabled, and then when you connect, you'll be able to see all the decrypted data here inside of SSMS. So that would be how you would see that, because Management Studio would be your application at that point. And also just one thing to keep in mind, you probably want to get the most recent version of Management Studio, which is compatible with database engines all the way back, I think, to 2005, because that has full functionality for like right-clicking and doing edit top 100 or edit top 200 and those sorts of things. But that would be the way that you would do it. Just add that encryption setting to the connection parameter.
All right. Last question. Can we join 2 temp tables on masked keys?
You cannot join the temp table. Well, I mean, you could join them on the masked keys, but you would likely not get the right results because the data in the temp tables will be masked. You would have to get the unmasked version into a temp table in order to be able to join those. So if you're a user, I guess the short version of this, the technical version of this is if you're the user that does not have unmasked permissions and you build 2 temp tables that contain masked data and you join on the masked columns in those, you're not going to likely get the right results because you're going to be joining on masked values. You would have to join the actual, but on the other hand, if you were to join the underlying tables, like if you were to take two regular tables that have masked data in them and join them on masked columns, then that would be perfectly valid.
All right, great. Well, thank you, Brad, so much for staying a little bit longer and answering some questions. Thanks again, everybody, for joining us today. As Brad said, any materials mentioned or seen in this webinar will be on his website, bradleyshat.com. We'll be sure to kind of retweet that and share that. So if you guys make sure to follow us on social media to keep up with that. If you have any additional questions, please email the email that came with your GoToWebinar information. We'll be happy to pass that along, or you can email Brad directly. Again, thanks everybody for joining us, and we'll talk to y'all soon.
Cool. Thanks, Liz. Appreciate it.